Kubernetes for Humans.
Hello, everyone, and welcome to another episode of the Kubernetes for Humans podcast. My name is Itiel Shwartz, and today we have in the show Alexei. Alexei, can you please introduce yourself?
Absolutely. And thanks for having me. Uh, Today, it's a great honor to be on this podcast.
So tell us a bit about yourself. What do you do? Where do you work? When did you start working with Kubernetes? And I'll say that this episode is going to be one of the for couple that we're going to do now around MLOps, LLM, and like GenAI in Kubernetes together. So you are the first guest that I'm interviewing on that topic, but if you can, introduce yourself a bit more.
Okay, sure. So I'm in software development for over 2 decades now, and diving into areas like software backend development, cloud architecture, DevOps, and lately even some AI. It was a pretty exciting ride, and my journey really started with passion to problem solving and building things. That's what I'm doing always. And over years, I always try to find or gravitated towards problems that are a bit messy, unsolved, especially in some complex distributed systems. As for the Kubernetes, actually, the journey started from Docker container. Initially, I was kind of fascinated by concept of containers, and I start to develop containers, start to learn how things work from under the hood. So that's why I built, for example, my first open source project called Pumbaa. It's a chaos testing for containers, quite a popular project. And when we start to use containers at scale, initially I worked with Fleet, if you remember Fleet from CoreOS.
I don't
Then
remember.
moved to,
What was like, share a bit more, and also if you can share a bit like where are you currently working, where did you work, like give a bit more background, like.
okay, I'll give it.
Mhm.
So currently I'm working in Doit. I'm working on platform team. And before joining, I also led a Doit team of senior cloud architects, consulting, helping Doit customers to work with cloud services and Kubernetes across multiple cloud providers like AWS, Google, Azure. And before that, I was a solution architect at AWS. And before AWS, I worked on small Kubernetes startup. It's called Fresh. We were building the ICD platform for Kubernetes.
Okay.
And the company still exists, but it was acquired by, I believe, Octopus Deploy.
Well, who's deploy? Like now the main product of CodeFresh is more like managed Argo, right?
Yes, exactly. And they are core maintainers of Argo. And also work many years in enterprise companies like HP Enterprise and Mercury Interactive and some others. So it was a long journey, as I said. And
So
with, go.
no. Now you talked about like you try and Fleet, like we talked about Kubernetes, and you mentioned like Fleet. So yeah, now when you try that, like where you working, Doit is like one of the like biggest in Israel in general, like service provider, right? Around like everything related to
Yes.
cloud. So yeah, now share a bit more about like the Kubernetes journey. I don't remember Fleet, I'll be honest here. So if you can like refresh everyone memory on that, and
So initially it was kind of CoreOS itself. So I like the concept of CoreOS. It's a tiny operating system with interesting concept of upgrading, like and then they released something called Fleet for continuous orchestration. It was based on systemd and some daemon that help you to orchestrate continuous running through the systemd. It's was the very low level. At the end, they kind of stopped this project because they switched to Docker Swarm, what another orchestration platform.
yeah. So what you were saying, like Fleet was before like Kubernetes was that popular. back
Yeah,
then
yeah.
the main popular were like Docker Swarm, right? Mesosphere and Kubernetes.
Mesosphere,
I don't remember like Fleet, I'll be honest. So it's even prior to that. And then you moved to another like container like orchestration that also didn't end up that successful, right?
Yes, and at the end, actually, I get to the Kubernetes and I like it a lot. It was kind of amazing. And but again, once you go deeper, you understand it's also a bit complicated. It's not
Mm.
that simple. It's kind of another layer of architecture on top of your existing infrastructure architecture. And the problems you solve at the infrastructure level, like virtualization and compute resources and networking and security, you need to solve them again at the container orchestration level. And suddenly you need to handle not only the way you are running your code, but also how you orchestrate your fleet of microservices. You need to deal with kind of networking, security, deployment, configuration, updates, a lot of headache. But again, what actually I like about Kubernetes was the community.
I agree.
Community is very good and very wide, and open source spirit. Actually, it really helped to get deep into Kubernetes, having this community around. You see a lot of solutions being developed around Kubernetes, like companies, your company, and many other companies develop services, solutions as open source, as commercial software. You can always find a few solutions trying to attack the same problem in different way. So it's a very rich ecosystem and a lot of people who are very familiar with Kubernetes around.
So you started working with Kubernetes, you are seeing a lot of companies. I know that you have a couple of like super or like very like popular open source project, and also quite a lot in the like MCP and like LLM in general. So like why LLM? Like you come from a very like deep infrastructure background, right? So maybe share a bit about your journey towards like learning LLM to begin with, like why, and also if you can share a bit about like LLM and Kubernetes and the good, the bad, and like your experience with that.
Sure. So actually, in Doit, I spent a lot of time helping teams to adopt Kubernetes, and one pattern I kept seeing is that even experienced engineer and DevOps engineers and developers found Kubernetes a bit overwhelming. It's very rich in terms of number of object relations, CRDs, configurations, tools. Kind of, it's hard to know everything. There is so much to remember for kubectl commands and YAML syntax and how you troubleshooting failed configuration and service. Like, you need to be a real guru here.
That's true.
And when something goes wrong, it's easy to get lost. Okay, so it's easy. At the same time, lately, like last year, a bit more, like 2 years, there is a rise of AI assistants that started like basic fun chat with AI, like ChatGPT. But of course, for last year, these are really, they help you to write a better code. They can help you with troubleshooting, and it's easier to translate natural language to concept like scripts and codes and commands you need to run. But I started to wonder why actually I need to chat with the assistant, why it cannot actually execute the commands, actually explore my environment and not give me generic advice. Okay, if something gets wrong, this is a generic way to find out. This is number of commands you can run, and to give me the output, I will say you.
Yeah.
So it's kind of ping pong game with the AI chat, and initially I started working on dynamic code generation and execution, not for Kubernetes, for AWS.
Mm-hmm.
And when Anthropic just released their Model Context Protocol, MCP, which is kind of, for people who are less familiar with MCP, I believe it's hard to be non-familiar with MCP right now, but again, it's everywhere. But people sometimes define it as a USB hub for AI integration. So it's easy to plug in different tools that follow the same standard for communication with the tools. And suddenly you allow your AI-powered assistant chat or whatever application you provide access to these tools, and the AI assistant can use these tools to get more information, to perform some commands or action instead of you. And then I realized it was kind of missing piece. I don't need to develop dynamic code. I can use tools that were initially developed for human, like for DevOps engineers, for people to use these tools. So I say, okay, let's try to give these tools to the AI assistant. And in case it is not aware about exact syntax of the tool, I can also provide the detailed list the exact parameters and give some example how to use the tool so it can learn while it's running. So that's how the actual idea to take kubectl and some other helpful tools and allow AI system to access these tools and execute them was born initially.
So maybe let's take like one step back. You're saying you wanted to have your own like chat, right? That will know your environment, unlike asking in Google or in like ChatGPT, like how can I solve this, I don't know, like pod problem. You want someone that knows your system, that know your clusters, that knows everything, and have much more context around that. And like with the new, I would say like Anthropic release of MCP and like its popularity, you wanted to do something similar to kubectl, right? So the goal is how can I enrich my LLM to be more, I want to say like smarter, right? But more context aware in the end of the day. Is that correct?
Exactly. To actually, if it doesn't access the tool, the model remains kind of static. It knows only things that for the time it was trained. And then it needs additional tools like web search if you would like to get some more actual information, or you need to context is the king in LM. If you would like to get a better answer, you need to provide more context to the model. Of course, you can go and extract the data by yourself, but again, you can give model access to your environment, to your information, to your documentation. And with MCP, it even took commands to execute some commands and figure out how to run them. Actually, I can imagine it like you have a really smart friend who knows Kubernetes inside out, and you can just talk in human language and ask your friend to help to troubleshoot things, to deploy something, to configure something, and it will tools like kubemcp server will do it for you instead of you doing it. Okay, so and it's kind of translator between AI and the Kubernetes environment you're working this.
And what's the feedback in the street? Like I know it was released as an open source project, and you also have one around AWS, right? Like I just so like how big is this ecosystem? Like how many people really care about it? Is it only a buzzword? Like share a bit about like the actual usage of those kind of LLMs in production or in like real life scenarios.
So I personally use it,
Mhm.
and I use it lately to troubleshoot ClickHouse installation on Kubernetes cluster.
Oh, cool.
It was a kind of misconfiguration because, I installed ClickHouse with some CRE with ClickHouse operator, and actually it has its own syntax to describing configuration that you need to learn how to describe it properly. At the end, it was kind of small misconfiguration that took time. For me, it would take time to figure out what was wrong. It was spell check mistake in namespace where ClickHouse should install itself. But actually, for some reason, it didn't record it as an error. So it was not visible from, expecting log and events. Everything was perfect, but ClickHouse cluster was not running. So you need to go and actually to explore a lot, to run multiple commands, to explore configuration, documentation, and also logs, events, everything till you permissions, till you find the real problem. Of course, you can do it, but actually AI can do it for you and can do it much faster. I also experienced like troubleshooting failed containers, where you can go and try to find why container is failing. Like nothing special, and people are using it. Again, I'm not monitoring the usage, but people asking me about question about for LinkedIn, from GitHub, contact me directly, asking how they can configure it, how they connect to the cluster. So mainly for troubleshooting scenarios, I would say. Since there are a lot of commands you need to run to figure out what's going wrong on there. And some also for creating ad hoc environments. I also used it for create ad hoc environments. For example, it's easy, it's possible, of course, to create Helm charts that you can describe. I would like my WordPress and Nginx or whatever running in this namespace. But if it's testing environment and you don't care, you don't need this Helm chart for long run, you can say, okay, please create me and describe whatever you want. You would like a auto-scaling group of WordPress servers exposed through Nginx Ingress on load balancer, and you will get it. You will get it within few minutes.
So like as someone who also we have our own like agent that helps you to troubleshoot things. I completely understand like the need. How well does it work? Like one of the things that were super hard for us, that even after working on it quite a lot, there were a lot of hallucinations. Like, do you see it? Does it happen? Like, what's your take around like how can I take it to like to the next level in a way, or like what's the main like challenges on like implementing something like that or using it, if any?
Of course, there are multiple hallucinations, but again, providing the right context and the right tools to the AI, and of course, relying on models that are able to understand instructions, like instructor models. For example, I used a lot Cloud Sonnet, but also tried it with other models too. Also local model, but for local model, you need to take construct model that are able to work with tools. And once the model has tools and understands that it needs to call tool to execute action or to get more context about the problem, it will hallucinate much less. I also use Context 7. I can recommend this MCP for up-to-date documentation about many tools and many open source libraries. You can always ask your AI first to validate the documentation using additional MCP. And then this way you kind of reduce number of hallucination. And again, it's AI. It's kind of try to run the command. Sometimes you see it tries to run it with wrong parameters. It see the error. Then it asks kubemcp server, please give me help how to run this command. As a result, it gets back the full list of parameters with explanation and some examples. And next time it run this command in the proper way, getting, and sometimes you don't have permissions, for example. So
Yeah.
there is another topic, security, but sometimes you don't have permission, so it tries a different way to get the same information. Probably maybe it can get it through another kind of API.
Mhm.
This is the way, but you allow it, you rely on AI to fix itself, and to use the tool to figure out how to call, to get the information, how to execute the command.
Okay, maybe like as a last question, I'll ask you a bit about the future. Like, where are we going as an industry? Like in like a year, 2 year, 3 years time, where is like this LLM for troubleshooting going? What do you think like are going to be the next breakthroughs? Share a bit on how do you see the space?
Actually, it's a great time to be. It's kind of many
Mhm.
people are scared from AI. Maybe we should.
Mhm.
I don't know, like many. Maybe in a few years there no place for software engineers, but currently I believe it's more a very powerful tool that actually multiply your knowledge and skills and allows you to operate in a very efficient way. I also see like a combination of AI and infrastructure together, where probably next gen Kubernetes or Kubernetes-like platform will be able, we will not have this kind of separation like we have today, like you have application and you have operation.
Yeah.
So you care about deploying your application and somebody else care about monitoring, logging, operating, and there is no connection between these two. Probably the system should be more self-aware and platform-aware, and the platform should be able to self-heal, to auto-detect failures, to know how to fix itself and how to fix the application, and probably developer or DevOps engineer will provide guardrails or common direction. This is what you can do in order to fix. This is the direction, but not to break the application, to scale it properly, not based on some CPU or some varied metrics, but understand it what happens behind the scene and what should be changed right now. If we need to add more resources, if we need, to save costs right now, if we need to even predict failure based on some patterns. I believe we are going into this direction more, like getting more brains inside, very powerful API based infrastructure.
Yeah, that's I'll be honest, like that's what we also see, and I hope it will happen as well. Any last word, Alexei, before we finish?
Uh, Probably, I need to think about it.
No.
Maybe some advice for guys who start with Kubernetes. I know the companies that, despite Kubernetes is very popular open source, it's everywhere, but actually it's not. There are many teams that are just starting Kubernetes journey, and they find Kubernetes to be a bit overwhelming, to be a bit more complex. And my advice would be patient and persistent. Kubernetes might have a steep learning curve, but it's very powerful platform, and once you adopt it, invest time in learning the platform, knowing how it operates, how it works. Even with AI tools, don't rely exclusively on the AI. It should use AI as a helper tools that accelerate performance, help you to troubleshoot, but actually you need to understand how Kubernetes operates under the hood. You need to know this technology before you adopt it.
Okay, I agree. I couldn't agree more. Alexei, thank you very much, and a pleasure having you.
Okay, it was pleasure. My pleasure.
Kubernetes for Humans.